So far we've assumed that the incumbent is sure that the rival exists. However, it may be that the incumbent is uncertain about whether there are any potential competitors. To capture the potential for uncertainty, we're going to introduce a probability ρ into the model. This probability ρ is the probability that the incumbent puts on the rival not bidding for the patent. When ρ is 0, the incumbent essentially believes that there's no competitor for the patent. When ρ equals 1, we have the previous model where they know that the rival exists and is prepared to bid on the patent. So we're going to go through the same process as we did before, but now with this probability ρ. As before, if the incumbent bids and acquires the patent, then they continue to get the monopoly profit πm. Now what happens if the incumbent does not acquire the patent? Then, with probability 1 minus ρ, the rival bids and wins, and each firm gets the duopoly profit. So 1 minus ρ here is the probability that the rival exists and is going to bid for the patent. With probability ρ, the rival does not bid for the patent and the incumbent will get the monopoly profit even though it hasn't acquired the patent. The incumbent's expected profit if it does not bid and acquire the patent is just the weighted average of πd and πm, where the weights are determined by the probability ρ. So the probability the rival exists and wins the patent is 1 minus ρ, in which case the monopolist gets the profit πd, and the probability that the rival does not bid is ρ, and the incumbent in that case will get the profit πm. So what are the two firms willing to pay for the patent? The rival's willingness to pay is unchanged from the previous case, it's still πd. On the other hand, if the incumbent bids for the patent and wins the patent, then they'll continue to get their monopoly profit for sure. Whereas if they don't bid, then they get the expected profit we calculated above. We can factor this expression as 1 minus ρ times the difference in the monopoly and duopoly profits. So which one of these is larger? Is the rival willing to pay more or the incumbent willing to pay more? Well, here it's going to depend on the value of ρ. As an extreme, if ρ were 1, that is the incumbent were sure that the rival is not going to bid on the patent, then the incumbent would not be willing to pay anything for the patent, and so the rival would be willing to pay more. On the other hand, when ρ equals 0, we're back to the case we had earlier on. So it's helpful to think of these two extremes. In the diagram here, I've plotted the willingness to pay of the rival and of the incumbent. And these are plotted against ρ, the uncertainty. When ρ is 1, the incumbent is certain that the rival will not bid on the patent. Now, when ρ equals 0, we're back to the previous case where the incumbent was sure that the rival would bid on the patent. And in that case, remember, we had the efficiency effect. So when ρ equals 0, we have only the efficiency effect. When ρ equals 1, then the incumbent is sure that there is no rival. They're not going to be willing to bid anything for the patent. And we have only the replacement effect. So remember the replacement effect from when we looked at the difference between the incentive to innovate of a monopolist and a competitive firm. Here, the replacement effect means that the rival has a higher incentive to carry out a gradual innovation because they're replacing a profit of 0 with a duopoly profit, whereas when ρ equals 1, the incumbent firm is replacing the monopoly profit with the monopoly profit, so they're not willing to pay anything. So when ρ equals 1, we have only the replacement effect and the rival is willing to pay more. Now for ρ between these two extremes, both effects are present, but in varying degrees. So as ρ increases, the replacement effect becomes more important. As ρ decreases, the efficiency effect becomes more important. And you can see that at some point, these two willingness to pay of the rival and the incumbent are equal. So to the right of this dotted line, the replacement effect dominates, whereas to the left of this line, the efficiency effect dominates. So we found that with a gradual innovation, if the incumbent does not put a very high probability on the existence of a rival, then they're not going to be willing to pay much for that patent, and therefore the rival is going to be willing to pay more, and the rival will be able to enter the market and we'll end up with a duopoly. Whereas if rho is quite low, the incumbent puts quite a high probability on a rival bidding for the patent, then the incumbent firm is willing to bid more and it's going to win the patent and continue as a monopolist. So far, we've considered just a gradual innovation. What about a drastic innovation? Remember, a drastic innovation is an innovation that makes the previous product obsolete. So the difference here is now that if the rival acquires the patent and enters the industry, then the incumbent's profits will be zero and the rival will become a monopoly and make monopoly profits. So compared to the gradual innovation case, this is going to increase the incentive of the rival to acquire the patent because they're gaining the monopoly profits rather than the duopoly profits. So let's go through the same process as before. If the incumbent bids and acquires the patent, then just as before, they'll stay a monopoly and get their monopolist profit pi m. The rival firm will get zero. If the incumbent does not bid and acquire the patent, then with probability 1 minus rho, the rival bids and wins. The incumbent gets zero, the rival gets the monopoly profit. It's no longer the duopoly profit, it's pi m. And with probability rho, the rival does not bid, the incumbent stays the monopolist despite not bidding for the patent. The incumbent's expected profit now, if it does not bid, is going to be slightly different to before. The difference now is if the incumbent does not bid, then with probability 1 minus rho, the incumbent firm will get a profit of 0. Before, this was pi d. The other part of the expected profit is the same as before. It's rho times pi m. So the expected profit if the incumbent firm does not bid is rho times pi m. So what are the two firms willing to pay for the patent now? Now the rival is willing to pay pi m. Before it was pi d. And the incumbent is willing to pay pi m minus rho pi m. So pi m, remember, is the profit the incumbent gets if they win the patent. They get that for sure. Whereas if they don't bid for the patent, then they may still remain a monopoly, and that happens with probability rho. We can factor this expression as 1 minus rho pi m. So for example, if rho equals 0, then the monopolist is willing to pay pi m. Remember, rho equals 0 means that the incumbent is sure that the rival exists. In that case, both the incumbent and the rival are willing to pay pi m for the patent. They're willing to pay exactly the same. On the other hand, if rho equals 1, the incumbent is certain that there is no rival, then the incumbent is willing to pay nothing for the patent, and so the rival will win the patent and become a monopolist. As long as rho is greater than 0 here, the incumbent is willing to pay less than the rival firm, because the pi m will be multiplied by something less than 1. So we found that in the case of a drastic innovation, as long as there is at least a little bit of uncertainty about the presence of a rival, then the rival is willing to pay strictly more than the incumbent, and so we will have a market where the incumbent firm is continually being replaced by a rival firm that's coming in with a new innovation that makes the old innovation obsolete. So in the case of a drastic innovation, we have what's called creative destruction. Each period, the incumbent is replaced by a new firm with a new product, and this is continually happening over time. This is in contrast to the case we had with the gradual innovation, where we had persistence of monopoly. The monopolist would be continually innovating in order to deter entry of a rival firm. To summarize, the incumbent firm tends to have a greater incentive than the potential entrant to perform R&D towards a gradual innovation. However, if we introduce uncertainty regarding the threat of entry, or if instead the innovation is drastic, then a potential rival may have a greater incentive to perform R&D than the incumbent firm. Now remember, the reason that the incumbent firm tended to have a greater incentive to perform R&D in the case of a gradual innovation was that the monopoly profit is usually larger than twice the duopoly profit.